Hello everyone, welcome to this video which is going to be a culmination of all of the things we've been talking about in this topic so far. We are finally now going to get into the process of factorizing what we call quadratic trinomials. Now in this video we're talking particularly about monic quadratic trinomials. Let's just define what that means before we go on. So all quadratic trinomials, these quadratic expressions we've been working through, especially when we expanded in our FOIL method, for example, the answers there, or some of the factorization we've done, you may have noticed a lot of these expressions came in this form. Now, what these three pronumerals mean, these are just coefficients. These are just a representative of any numbers in front of my x squared or my bx, as well as my whole number at the end. So these three things are just the coefficients. That's what A, B, coefficients. These are just the numbers in front of x squared, x, and then this last number down the end. Now, monic quadratic trinomials, this particular word here, all this means is that when my coefficient of A is 1, that's all a monic trinomial is. So I'm going to write that down here before we move on. So a monic trinomial, or monic quadratic trinomial, let's just leave it as monic. A monic quadratic trinomial is when the coefficient A is 1. That's all we mean by that. So for example, something like x squared minus 2x minus 8, this thing here is monic because remember, when we have nothing in front, when we have no coefficient in front of my x squared or x, what is implied here is that the coefficient is actually 1 here. So in essence here, A equals 1. The coefficient A in front of x squared is 1. Okay, so we've defined now what a monic quadratic trinomial is. And for the remainder of this video, I'm going to take us back to the FOIL method. And before we can even think about factorizing and using what we've been doing so far, like a lot of things in maths, we want to see a pattern. So we said before that factorization is the opposite, reverse direction of expansion. So in order to understand factorization, we need to look at expansion and the patterns that arise in expansions. So this video is all about finding a pattern. So if I gave you one binomial product, so let's say x plus 2 x minus 4, and I wanted to expand this. Well, by now we should all hopefully be comfortable with expanding. We can just use our FOIL method, or in other words, we just want to multiply all of these terms by one another. They all have to interact. So what I'm going to do here is I'm going to work through this just like any other question. X times x gives me x squared. X times minus 4 gives me minus 4x. 2 times x gives me positive 2x. And 2 times minus 4 gives me negative 8. So this is all revision to stuff we've already done so far. But we're going to have a think about each of the resulting terms that occur here. So we had our first step. We considered this binomial product, we did the actual expansion, and then the last thing we ended up doing to get a quadratic trinomial was to just collect the like terms, because we noticed that there's a 4x, a negative 4x, there's a 2x, so we're going to add those two together. So we're going to get x squared minus 4x plus 2x gives me minus 2x, and we have minus 8. So this is the final part of our expansion. Now, I want you to consider the order in which we've done this. So we have step 1, step 2, step 3. And I want you to have a think about anything you can notice between this number. Let me do this last one in black so the highlighting works a bit better. So I end up with x squared minus 2x minus 8. I want you to have a think about, how does, for example, this number relate to my two numbers here? And how does this number maybe relate to those two as well? Take a moment to think about it. If you don't see a pattern yet, like a lot of things in maths, that doesn't matter. We're just going to keep doing a bunch of expansions and see if we can figure out a pattern. Now let me do two side by side here, two expansions. This may be a bit easier to visualize. Let's say here I had x plus 2, x plus 3. I wanted to expand that. And then here I have x minus 5, x plus 2. Okay. I'm going to do these side by side, one by one. You can pause the video and do them on your own if you'd like to practice. Now, in this first one, I'm going to go through this a bit quicker because the point of this video isn't to revise how to do this. It's to look at patterns that are observing, that end up coming up, that we observe. Let's do it in black again. When I expand this, I'm going to get x squared plus 3x plus 2x plus 6. And then finally, when I collect the like terms, I get x squared plus 5x plus 6. Doing it side by side with this one, I'm expanding to get x squared plus 2x minus 5x minus 10. And finally, I get x squared minus 3x minus 10. Okay, once again, I've done two more expansions. I want you to have a think about, how do this term and this term relate possibly to these ones here? Because we want to try to make sense of these numbers. We want to relate the integers we get at the end with the integers at the start. And I'm going to do the same thing up here with all of these. Now, let me ask you to think about yourself. Do we see a pattern emerging? Do we notice any similarities between the numbers we end up with down the bottom? So once we finish our expansion, these numbers as well as these numbers, do we see any pattern happening between the top? Now, if you don't see it, that's okay. Sometimes it takes a few more attempts, but to save time, I'm going to spell it out here. So if you notice, taking this 5, for example, do you notice I can make 5 by adding 2 and 3? So this coefficient in front of x, this b, if we look up here in our general layout of these quadratic trinomials, my coefficient of b ends up being, the sum of the two integers, or just the two numbers in my binomial product. And the 6 here is actually the product of 2 and 3. So if I multiply 2 and 3, I get 6. Now that could just be a coincidence. Let's have a look at all of our examples. Let's actually go back to this one. So -2, once again, we get -2 by summing 2 and -4. And we get -8 by multiplying 2 and -4. Over on this side, my -3 is a sum of -5 and 2. When I take -5, I add 2 to it. The sum of those is going to be -3. And the product of those two is -10. Now, observing these patterns and coming to this realization is a pretty groundbreaking thing in this study of quadratics. And it's going to tell us a lot about when we want to factorize. And when, like I said before, I'm not going to talk about the factorization just yet. We'll save that for the next video. But if you think about this idea of sums and products, it makes sense that these coefficients, or these pronumerals b, so for example this one, as well as c, would be what they are. Because think about this 6, we made that from timesing 2 with 3. So that makes sense that that would be the product of those. And this sum here, 5, it makes sense that we got that because those were the like terms that we ended up adding. We ended up either adding or subtracting those. But adding a negative number, doing a negative number and adding a positive, it still ends up, in essence, we are looking for a sum. So each of these things, what I'm trying to get at is it's not an accident that these just look like this. These numbers are working through a sort of pattern, like in this case as well. The -10, that makes sense that it was a product because right at the end, when we multiplied the two integers, just by considering binomial products, it's in the name, product. We are multiplying. And these two middle terms here, we are summing. So this coefficient c, the number at the end here, we call that a constant as well. We'll talk about that a bit later. But that pronumeral c, we get from multiplying, because that makes sense. We are timesing the two numbers at the end. It's the L step from our FOIL method. The middle ones, we always do this in between step of expanding it all, and then we simplify the like terms. And this is a process of algebraic addition or subtraction. So this is a pattern that we notice. So if we have any particular quadratic trinomial, so I don't know, x plus 4 and x plus 6, for example, we can almost anticipate what this is going to be. When we expand this, I'm always going to get an x squared at the start, if this is a monic one. Both of the coefficients of x here are 1. My middle term is going to be a sum of this term and this term. My b, I should say, so the b in front of x is going to be a sum of those two. And the c is going to be the product of those two. So I'm just going to fill them in now, and we're just going to double check that when we end up expanding. So this should be 10 and this should be 24. Now let's just check by using our FOIL method, the same techniques we've been doing up until now. I'm going to multiply the first two, x squared plus 6x plus 4x plus 24. And when I collect my like terms, so when I add 6x and 4x, I wind up with 10x. So this is how we can think about the things we've been doing so far, but just through the lens of this pattern. And this is going to inform a lot of the factorization we do in the previous video. And you'll notice that I left this in-between step. I didn't just skip ahead to the end, because you'll see in the next video, the middle step is important. So let me write that here. So middle step is important. And we will talk about that a lot more in the coming videos.